In this video, we're going to take a look at the difference between something called experimental probability and the theoretical probability that we've already looked at. So in the name experimental probability, we see an important word there. We see the word experiment. And think about what you know about experiments. You probably do them in science class, maybe you've heard it in other contexts. Experiments are where we do something to test a hypothesis. We want to see what's going to happen. So with experimental probability, we actually do something. We carry out that simulation or experiment. So carry out means to do it. So we're no longer just looking at the spinner. We're no longer just looking at the cookie jar. We're actually going to spin that spinner. We're actually going to pick cookies out of the jar. We're actually going to pick cards, roll the dice. And we're going to record data from that experiment and see how many times that favorable outcome occurs. And then our total is going to be the number of trials in the experiment. So how many times did we do it? How many times total? And then that number of favorable outcomes is pretty much the same as what we do. The key here is that the experimental probability is usually going to be different than the theoretical probability, because even though it's not likely that I could pick the same card out of a shuffled deck 5 times in a row, there's still a very small chance that that could happen. But in general, the more times we do an experiment, as the number of trials being the number of times that we do something, as that number of trials increases, the experimental probability gets closer and closer and closer to the theoretical probability. So that's something called the law of large numbers. So we know, for example, that there's a 50-50 chance that if I flip a coin, I'm going to land on heads. So if I were to do that experiment twice, I could get heads both times. If I do it 10 times, I might get 6 heads out of 10. If I do it 100 times, I might get 53 heads out of 100. It'll get closer and closer to that actual theoretical probability. So the trickiest thing here is determining what we're being asked to find and figuring out what data we need to use to find it. So it's going to involve a lot of close reading and making sure we know what we're being asked. So in this first part, we're going to determine the theoretical probability. So let's see what you remember. Go ahead and pause the video and try and find the probability of spinning a green and the probability of spinning red or blue. All right, so the probability theoretically of getting green is 1 out of 4 total. Red or blue, there's 1 red plus 1 blue. That's 2 total that we'd be happy with out of 4, which is 1/2. So now we're going to find the experimental probability. So this is after we did the experiment. And here is our data. So when we talk about experimental probability, we have to use data from an experiment. An important thing to note here is that the spinner is spun 20 times. And if we didn't know that, we could add up all these trials. 8 plus 4 is 12, plus 6 is 18, plus 2 is 20. So we would still get that same total. So for experimental probability, the total is always going to be the number of times that we did it. Now if I look at the data, I can see that I got green 8 times. And we reduce this, we can divide each of these by 4. So now we have 2 over 5 for the experimental probability of green. And then red or blue, we have 6 reds and 4 blues, just pulling that right from the table here. That's 10 out of 20, which is 1/2. So if we wanted to compare, we can see that the theoretical and experimental probabilities of red or blue worked out to be the same, but probability of getting green worked out slightly differently. And again, that's going to happen just because it's always up to chance. All right, next, go ahead and pause the video and determine the theoretical probability of flipping heads and the theoretical probability of flipping tails when we flip that coin. All right, so on a coin, there's 2 options. There's the heads and tails. So each of those is 1 out of 2. Now we have data from an experiment. So we did the experiment. And we flipped our coin 10 times, and here is our data. So when we talk about experimental probability, we're going to use that data. We flip this 10 times. If I add these for tallies, each group is 5 plus the extras here, so that's 6. Here we just have 4. So our total is going to be 10. And if I look at this, we can figure out the number of heads. There were 6 here out of 10. We divide each of those by 2. We get 3 over 5 for the experimental probability of heads, and 4 out of 10, which reduces to 2 out of 5. So again, these aren't exactly equal, but they're close. All right, next up we have the results of 50 rolls. So anytime we see a word like results, that is going to be a clue that we're looking for experimental. We know that we had 50 total. So I want you to pause the video and try and answer these 3 questions. The experimental probability of rolling 1, again, experimental, using data in our experiment. Theoretical probability, just looking at the number cube, thinking about what should happen. And it's numbered 1 through 6. So there's 1, 2, 3, 4, 5, and 6. And then which is greater? We're talking about 3s now. So pause the video and try those out. All right, so if we're looking for experimental probability, we're going to go to that data in the table. I can see that there are 10 times that we got a 1 out of 50 total. So 10 over 50 reduces to 1 over 5. We can divide each of those by 10. Next, for theoretical probability of rolling a 1, there's just one 1 on the number cube out of 6 total, so we have 1/6. Next, and I read this wrong earlier, I'm sorry, we wanted probability of rolling a number greater than 3. So if I look at experimental probability for numbers greater than 3, that's going to be 4, 5, and 6. So altogether, that's 30 times that happens. So 30 out of 50 is 3/5. Theoretical probability, there are 3 choices out of 6 total, so that is 1/2. If I look at these 2 fractions, it's actually a little easier to compare. So think about a cake cut into 5 slices, and that same size cake in a different version cut into 6 slices. In the 5 slice version, those are going to be a little bigger. So 3/5 is bigger than 3/6. So the experimental probability is greater than the theoretical probability. All right, for our last question here, we have this spinner on the right-hand side, 3 total options. It is spun 100 times. All right, so we are doing an experiment. Each trial is recorded in the table. All right, so this is our data. Based on the results, we want to know, is the theoretical probability of the arrow landing on the shaded section, so this one right here, greater than, less than, or equal to the experimental probability of the arrow landing on the shaded section. So go ahead and pause the video and try this one on your own. All right, so for this one, we want to start with the theoretical probability. There's 1 shaded section out of 3 total, so that's 1/3. For experimental probability, we have 36 shaded sections out of 100 trials that we did. And if we reduce that, we get 9/25. So if I'm not sure how to compare those fractions, I can always turn them into decimals. So 1/3 is 0.333 repeating, 9/25 is 0.36. This is the greater number. So that means that the theoretical probability is less than the experimental probability.